Hello everyone. In this video, we'll be talking about a data structure called as the stack data structure. And this is the topic which we'll be picking up in this as well as a few upcoming videos. So we'll be having a very detailed discussion on this. So what all can you expect from this and the upcoming videos? So we'll begin with the basic definition of stack, like what a stack is, what are the different operations, like the basic operations which you get to perform on the stack data structure, and so on. And then also there is a concept which you might have heard called as Lifo, the last in first out. So this concept is often accompanied by this term stack. So we'll be looking in a detailed fashion of what this Lifo actually means, and then we'll move on to discuss some basic problems of stacks, uh, just to give you a feel of how everything works using stacks. And after that, we'll be discussing some good level problems, like some standard problems. And what do I mean by standard problems? So, by standard problems, I mean like you can expect these problems to be asked from you during your coding rounds, during your coding rounds, or during uh, your interviews, right? So, without any delay, let's just start. So beginning with what a stack actually is. Now, if you just search the literal meaning of a stack, like the stack meaning, what we get in the result is a pile of objects, typically one that is neatly arranged. All right. So let's just try to understand what this actually means. So everyone knows what a pile is, right? So in this picture also we have a pile of these stones, which is neatly arranged in a particular fashion. So this is a important thing to notice over here. Like this stone will always be arranged in a particular pile. So suppose if we try to remove this particular stone from the middle of it, so our neat arrangement, which we just read, like the neat arrangement will get destroyed. How? You can easily imagine that all these stones will fall off and our entire stack will be destroyed. So it won't stay intact. So our objective is not to destroy the stack, but to keep it intact. So how do we do that? So now let's imagine you have to remove a particular stone from this. So like I just said, you cannot just remove any random stone from the middle of it because it will lead this stack to fall off. So what we do is we remove a stone from the top of it, right? And our rest of the structure stays intact as it was. So let's say we remove this stone. Now we have to remove yet another stone. So just imagine, like after removing this particular stone, what will be our new top? Like if we try to look it from the top view, we'll see this particular stone. And now we can remove this particular stone, which will be again pointed by this top. And then in a similar fashion, if we want to remove this particular stone, again our top will first come here, and then we can remove this particular stone from the stack. So like in real life, what top is nothing but the top view of this particular structure. But programmatically speaking, you can think of this top as a pointer which always points to the top element which is present in the stack. So like if we have these elements of this particular stack is stone, so this always points to the topmost stone. Okay, so like this was just a basic definition of what stack is. Now let's just try to understand it in a bit detailed fashion. Like why do we actually need stack? Or let's see some real life examples of stack. So suppose I open up a new tab and I search in here google.com, right? Now Inside this Google, I again search for stack, and inside the stack, I open up this particular Geeks for Geeks link for stack, and finally I land upon this page. So what I essentially did, or what actually happened at the back end of all what we were just going through, is is the fact that there was a stack being implemented which we couldn't see. Like let's understand this, how that was that. So we'll be understanding the entire stack using this particular bucket. So you might have used this kind of bucket some time in your life. So we'll understand the entire concept of stack using this particular bucket itself. So now what just first happened is we landed upon a page called google.com. Like we opened up this particular URL. And then on top of it, inside this google.com, what we did was we searched for stacks. So like let's say it was something like google.com/stacks. Not exactly this, but just for our understanding, let's just make this short. And then we again opened up another search result which came out of this, which was a Geeks for Geeks page, GFG/stacks. Let's say this was this. Okay. So what we can essentially see over here is happening is that we first pushed in this particular URL, and on top of that, this particular URL came up, and on top of that, this particular URL came up. So imagine what might happen if we just press the back button over here. So the Geeks for Geeks page is gone, and now we can what we can see is just this google.com/stacks page. It is a long URL, but to understand, I'm using stacks. Yeah. So like this GFG/stacks page was gone, and this was gone, and now we can just see the google.com page. So can you get a feel, like we are always able to see what is on top of the stack? Like when the GFG/stacks page was there, we could only see this particular page. We weren't able to see google.com/stacks or google.com. Now when we popped off this GFG/stacks from the bucket, so now I used a term called pop. So what this basically means is like we remove this element or this particular website from the stack. So what I came across was this google.com/stacks page, right? And this became our new top. So similarly, if we pop off this particular google.com/stacks, so we'll end up on this google.com, which will become our yet another top, right? So like let's just do a back over here, and there we go. We get this particular google.com page. Now, what if we press the redo button? Like there is this redo button. So we'll again come back to this particular page, which was google.com/stacks, right? So what we did essentially was we inserted this google.com/stacks on top of this google.com back again, right? And then again, if we press the redo, the GFG/stacks will be inserted over here. So I guess you got a complete feel of how the stack works. I explained it to you through a real life example. So like this is how the back button, like this particular button, back button, and the forward button of a website works. It works using a stack at the back end. All right. So like if you want some other real life examples, uh, so like one very good example is when you work with something like, let's say, Google Docs. When we are working on Google Docs, or as a matter of fact, okay, I'll have to log in, but okay, let's just log in, and let's just open up something, a blank page. Yeah. So like suppose if I type in something, some random thing, or maybe let's type like, hey, we are learning stacks. And now suppose I select this and I just cut it from here, okay? Or maybe like control X, so like this particular is gone. So now I have two operations. Either I can redo it, like control plus Z. So basically undo, sorry, not redo, like undo this operation, control plus Z, and this came back. Or I can redo this correct operation, control plus Y, and this went back. So like this particular undo and redo operation is again done using a stack. So you can imagine it like this. Like we had this particular thing inside of our stack, and while doing a redo, what we did was remove this particular element. And while doing an undo to the cut operation, what we did was we pushed this element back into the stack. So like this is yet another example of how the stack works in the real life. Okay. So like I have few images over here. In the real life, you can see that there are a pile of books or a pile of rotis. This is what a stack is. And now there is this term. Let's just come, like we just discussed in the very beginning. Like we'll talk about this particular term, the Lifo term, last and first term. So what does this mean? Let's just try to understand. So when we were uh, pushing in URLs like the google.com or the google.com/tags or the GFG page. So what was happening is what whichever URL came in last. So at this particular instance, the last URL or the most recent URL which came in was the GFG URL. So we were able to perform operations only with like we were able to remove only this particular one, this particular GFG site. And then again, what was the second last? So it was google.com/tags. So google.com/tags. So again, we were able to remove this particular thing from our stack, right? So what we essentially are doing over here, or even if we consider our example of these stones, so whichever is the last stone which came on top of this, like suppose we inserted another stone over here. Now, if we want to remove a stone, so only this particular stone will be removed. Otherwise, if we try to remove some random stone, this stack will obviously get distorted, which we don't want to happen. So this is the idea behind the LIFO concept, which stands for the last in, whichever is the last in, is the first one to go out, is the first out, right? So like basically this is the last stone which has just came in. So this will be the one which will go out. So I guess you got an idea of what LIFO actually means. And like the stack is the best data structure or which helps us to perform LIFO operations or any problem which might involve some sort of a LIFO operation. So this is an intuition of where you can use this stack. Just to give you an intuition, like we'll understand this better when we jump onto the problems. But for now, this is about it. And now let's just move forward to the next thing, which is what are the operations which we get when we are working with stacks. What are the operations which we get to work upon? So there are basically four basic operations, four different basic operations. So let's say let's see them one by one. So let's say I have this bucket, and now let's work with numbers to make things easy. So like suppose I want to push in a number which is 1 inside of this bucket. So what I mean by pushing is like I insert the number, I push or insert. So like this particular word push which I used is nothing but a basic operation which is also called as push inside of a stack. So it means nothing but inserting an element. So like suppose we push in 2, which will obviously come on top of 1. Like we cannot push 2 from the back of it because this side of the bucket is closed, right? So whenever we push, it will come from the top of it. So like we pushed in 2, and then let's say we pushed in a 3 on top of the stack. So a 3 came in. So this is nothing but inserting elements in the stack. Now imagine, like at this particular moment, our bucket is full, right? There is no more no more further space to push more elements. So what if I wanted to push another 4 inside of this stack? So what will essentially happen is that this 4 won't be able to get inside this bucket, and it will fall off from the top itself. So this particular condition in which the stack, in which we cannot insert elements into the stack as there are only as the stack is already full, this particular condition is nothing but known as a condition which is called stack overflow. Stack overflow. So some of you might have landed upon this very famous website, which is also called as a Stack Overflow. So you get the idea from where that term is derived. That is not any random term. It comes from this particular concept, which is of a stack overflow, right? So this was just an interesting fact to keep you interested in this video. Okay, so let's just continue. So now suppose I somehow want to insert this 4 inside of my stack. I don't care whether it is full. I just want to somehow insert it. So what will I have to do? Any ideas? Yeah, obviously. We'll just pick up this 3 and we'll take it out of the stack. So like let's say we remove this tree. Basically, we are removing this tree 3. So what this is, removing an element from the stack, which will always happen again, mind you, like this will always happen from the top of the stack itself. We cannot remove an element from the any random position, as we are always accessing it using a top pointer, right? Like we saw in our stones example as well. If we try to remove a stone from the middle of it, the stack will get distorted. So yeah, so this removing of an element from a stack is known as a pop operation. We are popping it from the stack. This is nothing but a pop operation. So like the 3 is gone, and we have this nice little space over here for our 4 to come in. So like now our 4 can comfortably come in without any stack overflow errors or this particular condition being there. So like this was about pop operation. And now just like we saw in the push operation, if we perform multiple push operations, there might be a condition where the stack becomes full and we are not able to insert further elements into the stack. So a similar case may arise with the pop operation as well. So let's suppose we popped out this 4, we popped out this 2, and we popped out this 1. So like this 4 came out, this 2 came out, this 1 came out. So at this particular moment, what we get is everything is popped out. So we essentially restored our bucket to the initial position, which was nothing but an empty bucket, right? So yeah, there we come up with yet another term, which is called empty. And this is nothing but yet another operation of the stack, which is called as the empty operation. So what this does is basically tell you whether the stack at the current condition is empty or not. So like if we perform the empty operation or the empty function we call at this particular moment, this will return a true. So this is basically a Boolean function, a bool function or a Boolean function in Java. In C++, we call it simply as a bool. So this will return you a true or a 1 on the output screen, which means yes, it is saying yes, the stack is empty. Also, if we had, let's say, 1, if we put that 1 back into the bucket, so at this particular moment the bucket is not empty. So like this empty function will return you a false or a 0 on the output screen. So this was about the empty function. Now let's imagine, like if I popped out this 1, and now I again performed a pop operation. So now what that essentially means is that I am trying to pop off an element from the stack pop off an element from a stack which is already empty, like there are no elements, and then I'm trying to pop off an element from the stack. So that does not make any sense, right? Like removing something from a stack which already has nothing. So that doesn't make any sense. Like that leads us to yet another condition, which is called as the stack underflow condition. And this will be an error. Basically, if you try to perform, uh, so this is not, this is basically a stack underflow condition. So let me just write it first. So stack underflow condition, right? So if you try to perform a pop operation on an empty stack, so this you will end up getting this type of an error, stack underflow error. If we pushed, if we tried to push when the stack was already filled, so we got an error called the stack overflow. And if we tried to pop when the stack is already empty, we get the stack underflow condition. Yeah. So now these were the the three basic operations, and I talked about four. So like one very important thing which we are missing right now is how do we know which element is there in the stack, inside of the stack. So there comes in yet another function or operation, whatever you may call it, which is called as a top. So if you are from a C++ background, this will be called as a top, and if you are from a Java background, this will be called as a peak operation. Right. So both is essentially the same, just the name is different. And as the name suggests, you might have even some of you might have even guessed by now. So what the top basically does is, like, let's suppose we have that 1 to 3 back in the stack, and this is our top pointer which is pointing to this 3 at this particular moment. So what this top operation will do is nothing but return us that particular element which is present on top of the stack, right? So what is there in the top of the stack right now? So 3. So it will return a 3. And similarly is the case with the peak operation, which is in Java. So it is nothing but the same thing. It will return the element which will be pointed by the top. So it will again return a 3, right? And let's suppose we pop off this 3 from the stack. So now we have 2, and this top shifts to this particular 2. And now when we again perform a top or a peak operation, so we'll get a 2 as the output. And similarly, if we pop off this 2 again and we try to peek in, so what we see that there is a 1. So we'll just get a 1. Now suppose if I pop off this 1 as well, so again my bucket becomes empty. So at this particular moment, the top pointer is not pointing to a particular element. Like the top pointer will be somewhere over here outside of a bucket below it. You can imagine something like that. So now if I try to peek inside the bucket, what will I find? I'll find nothing. So at this particular moment, the peak should again return an error, which should say either like the stack is empty, or maybe you can say a stack underflow error. It should give you that. So like yeah, so this was all about the basic operations of the stack. So just to recap a bit, what we just discussed is a push operation, which is nothing but simply inserting an element into the stack. A pop operation, which is nothing but taking out this element from the stack. The empty operation, which is nothing but is a boolean function which returns you true if the stack is empty. Like if there is nothing, so it will return you true, and if there is something in the stack like 1 2 3, so this will return you a false. And then we had our peak or top operation, which will return you the element which is on top of the stack currently, right? So these were the four basic operations. And apart from this, you may even see few other operations when you implement stacks using STL, the standard template library in C++, or maybe the collection framework in Java. So there you may see that there are some more operations available. Like one of them is size, which is also very frequently used. So this is nothing but a generic operation. Like even if you work with linked lists or vectors, there you get this particular size operation, which does nothing but returns you the size of that particular data structure at a particular instance. So like let's suppose we had this 1, 2, and 3, and we perform this size operation. So like this will return me a 3, which is the size of the stack currently. And if I pop off this 3 and again perform this size, so it will return me a true. And then similarly, if I empty the stack, pop off everything, then this size will return me a 0, like there is nothing in the stack. So yeah, so there is this size operation as well. But these are the main four basic operations which are originally meant for stack and not any other data structure as such. So yeah, so in this video we discussed about what a stack is, the basic operations of a stack, and of course and obviously the LIFO, like what does the LIFO actually means. And I just gave you an intuition, very rough intuition of how do of where will we use stack, like wherever there is something related to a LIFO, we will use stack in that. So like let's see this also with an example. So suppose if I have a word, let's say I have a word, the word stack itself, right? And if I maintain a stack of characters and I push inside one by one each and every word. So like first with S will come in, then T will come in, then A will come in, then C, K, and then S. Okay, S is not there. So like C and K. And now if I try to access the elements one by one, like suppose if I perform a peek operation or a top operation on this, so I get my K and I pop this off. Now from this I get my C and I pop this off. So whichever came in last is coming out first. So like we are following the Lifo principle of stack, right? And similarly, I come to this A, then this gets popped off, T, and then S. So what did we end up on the output screen? Like, so let's suppose we were just doing something like C out and the stack dot top every time before like C out stack dot top with the space before popping off the elements. So what we get on the output screen is nothing but the reverse of this particular word, right? So you get an idea. Like if we want to reverse this word, we can do it simply using a stack as well. There are other methods as well, like you can traverse from the back and keep printing, but then you can do it using stack as well. So this is a very basic problem or intuition which I wanted to give about you about. Like where exactly do we use stack? Wherever there is something related to LIFO. So while reversing the words also, whichever word came in the last, it came out the first, right? Okay. So with this, we wrap up on our very basic introduction of stacks. In the upcoming videos, we'll be discussing about how do we implement stack using arrays. So like first we'll be discussing how to implement it using an array, and then further we'll see how do we implement it using a more efficient way, which is using a linked list. So all right, catch you up in the next one.